It is Tuesday, the 17th of August, 2021, and it is video number 28 episode number 28 in the sequence. Today, I thought we would take a look at starting to consider some of the science of Parkinson's disease. It's very complex. I don't understand it all. I don't understand even 10% of it, but what I can do is talk you through some of the bits and pieces that make it up, and maybe you'll get the feeling that you might know a little bit more than otherwise. Let's talk about happy hormones. Yes, it's good to be happy. There are 4 chemical messengers in the human cell which are quite popular. They're known as oxytocin, serotonin, dopamine, and endorphins. These are hormones or chemical messengers which transmit status information between cells. It's how cells talk to each other. There's a lot of that going on, and some of the cells have some interesting messages, and some of those messages are good or bad or otherwise. But let's talk about the basic ones, the ones which are most implicated in the Parkinson's syndrome. We'll start with dopamine. This is Mr. P, Parkinson's. It's also known as the feel-good hormone or the reward hormone. It's called the feel-good hormone because if you don't have it, you won't feel very good. In fact, you'll feel pretty rough, and that is what is known as being down in the Parkinson's world. If you're down, your levels of dopamine in your brain have got to a very low level, and there are various strategies for dealing with that. Not on a permanent basis, unfortunately. So dopamine is associated with feelings of exhilaration, bliss, motivation, and concentration. It plays a key role in a range of body systems as well as functions, including movement, sleep, learning, mood, memory, and attention. How much attention are you paying to this? Well, if your dopamine levels are normal, probably something. Then there's oxytocin, the love hormone. It's also known as the trust hormone. It increases the amount of trust. When oxytocin is present in a relationship between 2 or more people, they will trust each other. It triggers the bond between mother and an infant. It can also play a role in the recognition, recognizing another person, sexual arousal, trust, and anxiety. Some research suggests that it can also be implicated in addiction and stress. So, yeah, oxytocin's kind of important too. Another one is serotonin, the calm hormone. Yeah, enough of that. This is the hormone of well-being and happiness. It is believed, and I quote, to help regulate mood and social behavior, appetite, and gastrointestinal function, sleep, memory, sexual desire, and function. If you ain't got it, you ain't got it. And if you ain't got serotonin, you'll be sad. Endorphins. Yes, endorphins are the willpower hormone. This gives you good habits. You're going to do something good, maybe endorphins will help you do it. These are chemicals produced by the body to relieve stress, pain. They can produce a feeling of euphoria that is healthy and safe. So it's a nice natural sense or way to get a euphoric feeling, and without being addictive. So dopamine is pleasure, and when we strive towards a goal with motivation, we can get dopamine as a reward for our efforts. Oxytocin is a chemical messenger which affects human behavior and relationships. And yeah, serotonin boosts our mood, makes us more agreeable and sociable, likable. It relates to your appetite as well and your sense of well-being. Endorphins, well, as I mentioned, it's about stress and pain. Dopamine is probably the one which is most strongly associated with Parkinsonism, and in particular the apoptosis, which is cellular death of the specialized cells which help to produce dopamine. So when those cells die, and they're not coming back, at least not easily, without medications which don't really yet exist, or maybe they do exist, we just don't know how effective they are yet. The apoptosis, or the cellular death, means that there is because of the particular cells which are implicated, there is a reduction in the amount of dopamine available in the human brain. And it does happen in the brain. This is where most of this is. It's a neurodegenerative disease, Parkinson's. That means basically it doesn't get better, and it gets progressively worse, so it doesn't stay the same, and it affects your neurology. So the cellular death of the cells which are mostly responsible, not exclusively, because there are other places which do it apparently, which result in the production of dopamine. When you start to lose that, you start to get many of the symptoms of Parkinson's. And that's why we use a chemical, a drug called Madopar. Oh, your one might be different. You might be on Cinemet or other things. But basically, this is an L-Dopa or levodopa. It is a chemical replacement that, when ingested and converted through the blood-brain barrier, will produce a kind of dopamine. So it gets you back to normal for a short time, at least until it wears off. And of course, there's all sorts of issues about wearing off takes longer and longer, or shorter and shorter, and yeah, you get into cycles of up and down. So that's probably a good starting point to leave it here. We've talked about the happy hormones, oxytocin, serotonin, dopamine, and endorphins. We've talked about dopamine's importance in Parkinson's. And we've talked about the cellular death being one of the fundamental causes. Now, we're going to be talking in future about what triggers that cellular death, what is implicated, why do the cells die. Mitochondria are somehow involved with this. Mitochondria, the so-called powerhouses of the cell, they are definitely there with a smoking gun around the death of those cells. So mitochondria is in there, possibly even a mitochondrial pathway, a way for mitochondria to pass through between cells. I don't know. I'm going to learn, hopefully. And maybe if we could find some way to stop the cells dying, we could arrest the progression of Parkinson's. If we could reverse the death of the cells, grow new cells which produce adequate amounts of dopamine, life would be a lot easier. And if we could find a way to increase the production of what we have, that would help too. So there are various options which are presenting themselves, but this is a long and complex disease, and there's no easy fix. We will be exploring a very intriguing phenomenon to do with lasers and light. Is there the possibility that cellular death can be impeded or even reversed by the application of appropriate frequencies of light in certain pulsed patterns? Well, I hope we find out, because I'm going to run a clinical trial on myself, and you're going to witness it. Yeah, lasers, man, lasers. The future is full of lasers and light. We'll see. Okay, thank you for your attention. We'll talk in the next episode.